Hello, my name is Robin Mitchell, and today Electropages is here at Embedded World Nuremberg. And today I'm at the Digilent booth, and I'm joined by Arthur Brown. So would you like to go ahead and describe what's going on here?
Yeah, so I mean, we've got a demo set up with both an Eclipse Z7 and then our Waveform software. This is usually used in some of our scope devices, oscilloscopes, logic analyzers, that kind of thing. The Eclipse is usually like an FPGA board for us, but we've just recently released waveform support for it to kind of make the getting started process a little easier. So for this demo, what we've got going on is a 3-axis accelerometer inside this ball that's being, its signals are all getting digitized into the Eclipse, and then the Eclipse is forwarding all that data back onto waveforms.
Now, on this Eclipse 27 is it? Sorry, 20. Yeah. Oh, or is that Z?
Z7.
Z7.
Yeah.
Sorry.
Zinc 7000.
Ah, right. So on this main board here, you've got two separate, what looks like sort of like channel interfaces. And each one of those is providing two channels. And are they then connecting to the board via a connector of some kind?
It says the G connectors. Yeah.
Ah, I can see at the back. Yeah. So they're not actually a part of the board, if that
right. Yeah. They come separately. There's some bundles where you can buy them together. You can switch them out for some other modules.
So you can do a bit of customization with it. And so the main board itself is focused around digital signal processing with FPGAs.
Yeah, exactly.
Brilliant. So, so in this example, we've got ourselves a green-looking ball, and I guess that inside it's got some kind of inertial control measurement
system. It's an accelerometer. Yeah.
So how is that being used with these waveform software?
It's really just sending data out, and like this is just acting as the glue. So it's like just straight data coming in from this thing and getting sent directly to waveforms, just passed straight on.
And so we've got 3 channels for 3 different axes. And as you move that ball, we can see it's changing around. And now, are these voltages coming out? But what I have noticed is that it comes back to the origin once it stops. So is this a rate of change thing as opposed to
it's just rate. We're not integrating any of it in this case. That's something that would be possible, I think, but we haven't implemented it for this demo.
Brilliant.
This is really just trying to showcase like how easy it is to set stuff up. We had one of our interns throw this together in like a day and a half.
Now, it's actually quite interesting to say because in terms of accelerometers, the ones I always see, you get some data back. But these are producing analog outputs, right? So have you got some kind of custom system in here to turn those raw readings into?
I think the actual accelerometer I see itself is just like, it can do both analog and then like SPI interface, but it's
and so you're just taking the raw analog data and then just plotting it onto these graphs.
Yeah, exactly.
Brilliant. So what other features can you tell us about the Eclipse board here?
So I mean, it's the Zinc 7000 part. Like when you're not using it with waveforms, it's entirely open, so you'd be able to like go in and program the FPGA yourself.
Oh, right.
And then the front end is super modular, so like you can also get like analog outputs. We've got like a digitizer module that's separate as well, and like that's got some different sample rates that it can apply pretty easily. There's a whole bunch of different ADCs that can get loaded. And
so you've got like a back end which interfaces with the waveform software, and then you've got the programmable part, which is the FPGA, which the customer could do their own thing. But then it interfaces with waveforms.
Yeah. So like when you're using it with waveforms, you don't have access to the PL.
Right.
It's not something we've implemented yet, but like as long as you're like doing your own thing, and like I've set up some demos on this thing previously where you're able to like DMA like a whole bunch of data, like a couple hundred megabytes into DDR, and then just like dump that over even USB serial.
I see. So in terms of the FPGA itself, how would that actually be programmed? Is that via, again, a USB interface, or is that?
Yeah, there's a USB JTAG interface.
So it's JTAG, so you just use your own IDE, whatever it is.
Vado, Vitus.
Okay, brilliant. So is there anything else you can tell us about the waveform software?
Yeah, so I mean, even in conjunction with the Eclipse, there's like a whole bunch of different instruments it can apply. So like it's both like what we're seeing right now with the scope view, but you also get like logic analyzer, protocol analyzer, all of that stuff is also implemented. So like the PMOD ports on the bottom here are also like just digital I/O.
Oh, those ones, yes.
It's all tri-stated 3.3 volts, so you can still.
Oh, that's brilliant.
Yeah.
And so they also act like outputs as well as inputs. So you can, I see. So it's like custom GPIO you could actually use, and so that would be used in conjunction with these channels, so you can make it do. So does that mean you can make it react to signals that it detects?
Yes, I think it still has to be software in the loop.
That's right. Because I know that waveforms is quite a generic, not a generic package. It's like it works with all your hardware, because I personally have an analog Discovery 2, I think it is. And that also uses waveforms. So
it's the exact same software.
And so and that's quite useful actually. So an engineer can use one suite
Yep.
with all the different tools.
Yeah, so like that goes from anywhere like the 82. Then like we have digital discovery, analog discovery pro devices, which we've introduced relatively recently that are all like much higher sample rate and bandwidth than a lot of our other devices might be.
Now, are there other applications that this thing can be used for in software engineering?
Yeah, I mean, one of the ones we've been kind of showcasing, so we released a ZMod digitizer recently. It's like plus minus 1 volt range and relatively quick sample rate, but it's like intended for use in SDR applications. So we've had like some people be able to use that for like even doing like, I don't know, pulse timing stuff.
Software-defined radio?
Yeah.
Oh, right.
So like there's a professor we've worked with before that was able to implement like a GNU radio.
Because that does seem to be getting quite popular these days, SDR. For sure.
Yeah, we hear about it a lot. But
yeah, that's interesting. Fantastic.
There's another demo set up.
Oh, we'll definitely take a look at that in a second then. Brilliant. So now we're at the second demonstration. Could you tell us what's going on here?
Yeah, so I mean, we've got Edis is another like NI acquisition that we've been working with a fair amount.
Right.
So in this case, it's a USRP B200 Mini. It's just a little SDR card, and we've got like an antenna set up. In this case, there's some issues with the hardware because like I'm pretty sure the roof is made of metal. It's blocking most of the.
Oh right, yeah, that's not going to be easy, is it?
Yeah, it's not great for SDR.
No.
But yeah, I mean we're being able to like still capture some data and get like a decent peak.
So this is a dedicated SDR.
Yes.
Yeah.
Yep. Yeah. One RX, one TX. And,
right.
Yeah.
Right.
And then, yeah, it's there's a GNU radio setup here that's doing some processing of the data and then converting that into audio. It's like capturing FM data and then, receive that, demodulate, forward it onto the computer. If we weren't just getting static, we might be able to play some audio out of the computer itself as well.
But unfortunately, due to the metal roof, we're probably not going to get that.
Yeah, exactly.
So what kind of applications could engineers expect to use this device? That's a loaded question because it could be anything to do with SDR, isn't it, really?
Yeah, realistically.
Pretty much anything radio-wise.
Yeah.
Actually, what I should ask is, what frequency range can we expect out of this device?
Right. So I think that this thing targets like a 70 megahertz to like 6 gigahertz bandwidth range.
Oh, that's pretty wide.
I'm not entirely sure. I don't know that much about SDR myself, and I'm still just kind of learning about it.
But even if it is around that range, you can definitely do low frequency, kind of like I say, FM radio stuff, all the way up to 2.4 gigahertz Wi-Fi, Bluetooth, that kind of thing.
Yeah,
and so an engineer could use this tool to view packets and measure the energy coming from their devices.
There's another demo that someone had been working on that was like capturing data coming from planes, like kind of transponder data.
Oh, ADSB and stuff. So that's that's your. Is that 818 or is that 9?
I'm not positive.
Oh, I think it's 890. No, 1090. It's 1090 megahertz.
Yeah.
That's what it is. Yeah. ADSB. Yeah.
Yeah, and just like being able to like pull that data down and like decode it, and then like actually view the packets like real time.
That's pulse width modulation. So it's quite easy to decode it.
Yeah.
So does this device support decoding as well of data packets, or is it just specifically trying to just pull the raw data in the first place?
I'm not positive where the decoding happens. I think it would be happening in the computer itself.
The software itself.
I'm not an expert.
And so could you give us a bit of an idea of what's going on with the software here?
Yeah, so I mean, in this case, it's a pretty straightforward, like I think it's a Qt-based GUI, but I mean, we have like a slider to try to like change the center frequency of like where we're picking stuff up, and then, I mean, the volume slider. There's like a search mode on this like demo as well, where it like scans through a bunch of different frequency ranges to try to identify spikes.
So is this designed to be used with your own custom software?
Right. Mm-hmm.
Right, that explains a lot, because so what you've actually got here is it's like an example project which you've created from a software point of view.
Yeah. So,
but the engineer could make their own.
Yeah.
Right. Okay.
Full GNU radio flow graph in this case.
This is much more interesting. Yes, there we go. And so is this a tool that engineers can use to try and do their own thing?
Yeah.
And so it's clearly it works on blocks where you connect blocks to each other.
Yep. And what I was mentioning earlier with the Eclipse is that like we had someone like design, like put together a support package for that, like with the same software, where they'd be able to use the exact same software that you'd be used to in some SDR applications to like design your way up to like a full demodulator.
Interesting. That's brilliant. So just before we wrap up this video, if there's an engineer who's watching this video and wants to get involved with this equipment and Digilent itself, what would you recommend they do?
All of our documentation, all of our resources are all available on our website, both between like the web store and then the resource center for the device itself talks about all of this stuff. So yeah, I'm on the support team. We write a lot of that material.
Fantastic. Well, thank you ever so much for taking the time to see us today.
Yep.